Hi folks, let's get started to learn Spark. Spark is very useful tool like in big data analysis, in machine learning, and in data streaming. So let's get started with Spark. We don't need to install any packages, any binaries in our machine. We can just use Google Colab. It's very convenient. And I will share my Google Colab link later. So let's start it. First of all, let's install something we need. We need to install JDK since Spark is implemented by Scala, and we need to get some Spark code and use Spark here. So we're using this version. Now Spark has version 3. But this version is also pretty up to date, so it's fine. Okay, it may take 1 minute. Yeah, the memory is pretty large, like 13 gigabyte. Okay. The most important concept in Spark is called RDD. RDD, it's a fault-tolerant collection of elements that can be operated in parallel in Spark. There are two ways to create RDDs. The first way is we can use this parallelize function. This function can convert a Python collection to an RDD. For example, this data is a very simple Python list. When we use spark context.parallelize, we can make it an RDD. You can see there are two parameters. We don't need to pass the second parameter. The second parameter tells Spark like how many partitions we want. By default, Spark will make decisions automatically based on the cluster. You can also pass the partitions explicitly like 10. In general, for example, if you have two CPUs, you can make the partitions 4 to 8. By default, Spark will make decisions automatically. So we don't need to pass the second parameters. Let's print this stuff to see what's this. So we can see it's a Python RDD. So it's a wrapper of the Python collection. What if we want to say what's the real Python collection, the real Python data? We can use collect function. The collect function, it returns a list that contains all of the elements in this RDD. So we can see all this data. Okay. For example, we can run the reduce function and to get the sum of all the elements. If the data is very large, let's say 1 billion, and if we have many machines, Spark will run it in parallel, so it will be very fast. Okay, so the first way is to create an RDD is using this parallelize function. The second way is use function like text file. Let's see what text file is. Maybe this one. Okay, anyway, text file is a function that we can use to read data from Hadoop file system, from HBase, or some other file systems Spark supported, like Amazon S3. If we have a very large file, we can use Spark context to read this file from the file system, and it will be an RDD. Okay, there are some operations on RDD. Previously, we used this reduce function. Now, let's say some other examples. Let's say we have a simple file. There are only 2 lines. We can use parallelize to make an RDD from this file. Okay. When we print it, it will be this one. Okay. Now I want to count the total number of characters in this file. So I can use map function to map each line to an integer. The integer is the length of this line. So after the mapping, we got 5 and 13. Let's see, yeah, 5 and 13. Okay, now I can use reduce function. I can pass a function, or I can pass a lambda function here. Lambda a b. We can just return a plus b here. Yeah. So the reduce function give me the total length. Okay. So in Spark, there are two kinds of operations. The first kind of operation is transform, for example, map, filter, flat map. It creates an RDD from another RDD. Another kind of operation is what we call action. So action is it's a kind of operation that we want to get some results from it. For example, the reduce function, the collect function. It is something we want to get results from. So for transform, the calculation is lazy. For action, it's not lazy. Let's say all transformations in Spark are lazy. They do not compute the results right away. Instead, they just remember the transformations applied to some base data set. But for action, since we want to get some results, when we meet an action, so we will run all the calculations. And there's also persist function. For example, let's say a1 is a dot map, okay, some blah blah function, and a2 is a1 maybe some function, and the a1 is used a lot. Maybe b1 is a1 filter, and then maybe c1 is a1 dot maybe flat map. So a1 is used a lot here, and every time we do the calculations, we need to rerun the a1. Since a1 is used very frequently, it used a lot later, so we can persist the result of a1 in memory. So that we don't need to recalculate a1 every time. The result of a1 is persisted in memory. For passing functions to Spark, we have already seen a lot of examples. We can pass numbers. Okay, we can pass lambda function. We can also pass another functions. Let's see how to work with key value pairs. It's very common to work with key value pairs. For example, word count example, we have a large text files, and we want to know the frequency of each word. Let's see how to do it in Spark. Assuming this is our text files, so is there just 2 lines? First, we pairalize it, we make it an RDD. When we print it, it will be like this. Okay, now we need to use flat map. By using flat map, we can break each line into multiple words. So this is the result. Next, we use this map function to map each word into a pair. The key is the word, the value is 1, meaning it occurred once. When we print it, it will be like this. And finally, we want to reduce by key so that we have the final answer. Previously, I mentioned the first way is to use pairalize to create an RDD. The other way is to use some, for example, we can use function like text file. Text file is, it can read a text file from Hadoop file system or local file system or any Hadoop supported file system URI, for example, S3. Let's run this example. So we can upload a local file here. The example.txt is something I copied from Twitter. So we can upload this file, and the Spark context will read this file into an RDD. Let's print it. So it will like this. There are multiple lines in it. Next, we break each line into multiple words. Then we map each word to a key-value pair. Then we reduce by key. So I have the result, the word count result of this text file. Yeah. Okay, another example is we can calculate pi by using Spark. Assuming we have a square, like 2 multiplied 2 square. So the area of square is 4. If there is a circle in this square, then we know the area of this circle is pi. So we want to know what the pi is. Assuming we are randomly throwing many coins into this square, and some coins they are within the circle, and some are not within the circle. For example, we can throw 10,000 times, and we know how many times it's within the circles. So we know the probabilities those coins within the circle. Then we can multiply. Then the probability can multiply the area. So the area of square is 4. Then we get pi. Let's see how we do this in Spark. First, we have an inside function. So we generate 2 random numbers. If x squared plus y squared is less than 1, then we know it's within the circle. Okay, now we can generate a large Python list. Then we can use a parallelized function to make it an RDD. Then we can use this filter function, filter by the inside. Then we use .count. So this count is the number of times the coins within the square. Then we just multiply it by 4, then divide by the samples. Then we got pi. For example, we can throw 100 times. It's not accurate. When we throw more and more times, it becomes more and more accurate. Yes, but it will also become more and more slow. Yeah, but it's more and more accurate, right? Okay. In Spark, there's also stuff called data frame. Data frame is something pretty similar to SQL. Let's see an example. First of all, let's say text file is RDD. It does not have 2DF attribute. We can use Spark session. Okay, then it has 2DF function. 2DF function, it can transform an RDD to a data frame. Let's say we have Python list. Each element is a tuple. It has name, it has sex, it has age. Then we can call 2DF function. We pass some columns, name, sex, and age. Then the data frame, it's very similar to like table in MySQL, right? Okay, then we can group by age. It's also very similar to MySQL group by. And we can also run some filters. For example, I only want to keep those records whose age is greater than 19. Yeah. And assuming my text file is a very large log files, and I want to search some error log, then I can use this function, and to make it a data frame, it only has one column called line, and I can filter by line. I can find those lines. I can find lines who contains the error keyword. So it can be used to analyze the server log. Okay, that's it. That's a very simple introduction to Spark. Thanks. I will share the link later.